The unit circle and graphs of trigonometric functions. Consider the diagram below showing a unit circle and the graph of y equals sine theta. Now, before we look at this, I'm going to look at an app, which I think explains it really well. So here we have a Geogebra app. This part of the graph here is sine theta from 0 to 360. 360 is where the cursor is now. 0 is here. We know that sine theta is the y-coordinate of the point P, which is this yellow point here. So at the moment, at 0 degrees, the graph is just here because the y-coordinate is 0. Now if I start increasing the angle, let's go to 30 degrees. When I get to 30 degrees, this height is 0.5. You can see it mapped there. So as we increase the angle here, we're going up in terms of the y-coordinate here. So P is now at the point 30 degrees, 0.5. So what we're doing over here with the graph is we're using the angle as the x-coordinate and the sine of the angle, 0.5 in this case, as the y-coordinate. If we continue to increase the angle, you can see that we move to the right across this graph. And let's try to get to 90 degrees. The sine of 90 is 1. And so this point here is plotted at the coordinates 90 degrees, 1. Now, as we move around into quadrant 2, this red line starts to get shorter again. And so the graph decreases over there until we get to 180, where the sine is 0 again. And so we can see the point 180, 0. Now the y-coordinate is going to be negative. And so we get all those negative angles until we get back to 360 degrees. So that's how the unit circle is matched to the shape over here. When we're looking at the point here on the unit circle, the point P is at the x-coordinate and the y-coordinate, but over here it's the angle that's plotted against the y-coordinate. So that's what we're trying to show with this graphic here. So we're starting to move the angle around and P1 is plotted here. So whatever theta is here is the x-coordinate and the height of P1 is there. And then P2 was straight up, we showed that on the animation. Moving around here, remember the angle is now this angle, so it's obtuse. And then we plot the y-coordinate, so we get this point here. And that's how we build up the graph. What we're plotting here is theta against sine theta. So every point on here has coordinates theta, sine theta. We know that the sine of the angle is the y-coordinate of the position of P. The diagram shows various positions of P around the circle. On the graph, we plot the y-coordinate against the angle theta. We've spoken about that a few times. You need to be able to plot trigonometric graphs using technology, and I'll look at that here as well. However, it is important to know what we're doing here. So, this using our class pad, graph and table, just clear anything I've got there at the moment. And I'm going to put in here sine x. And I'm in degrees, which is okay. and then I'm going to plot. And I probably won't see very much to start with, but if we change the x to be 0 to 360, and the y, let's go -2 to 2, and that should give us a nice picture of the sine graph. The sine graph has a maximum value of 1 and a minimum value of -1. Just for the sake of interest, if I go 0 to 720, you'll see you get two waves. Once you've got 0 to 360, you've really got it for any angle at all, because you essentially just cut and paste this section of curve.